in section 6.2, we're going to be working through logarithm functions. And before we get started with the definition of this, I'm going to take a minute to explain the very important reason that we need logarithm functions in the first place. So in 6.1, we did our exponential functions, and they were of that format: a equal to a0 times b raised to the t power, where t is our input variable for this, the independent variable in the function. And our issue with this is, what if we want to solve for t? A lot of times that's time, and sometimes we might want to know how long it will take for something to happen. And unfortunately, our standard algebraic methods, add, subtract, multiply, divide, do not work to be able to solve for t because it is in the exponent. We don't have an easy way to get t out of the exponent with our standard algebraic manipulations. So that's where logarithms come in. Logarithms give us the ability to take this variable that's in the exponent and make it not be in the exponent anymore. It gives us a nice simple way to essentially take it out of the exponent. We have properties with that we'll do in a later video to be able to solve these exponential functions for the input variable. So in this class, we are only going to be looking at the common logarithm. This is the standard one that should be on your scientific calculator. Your scientific calculator has two logarithms on it, the natural log and the common log. We're only going to be looking at the common log one, which is base 10. It's the one that just says log on the calculator. You should be able to find it on there. So our definition of a logarithm, of the common logarithm, is a positive number where the positive number a, where the is the number b, where 10 to the b is equal to a. And I should probably add in that this is for the common logarithm. And usually we write this as being log of a equal to b. And now we can switch between the logarithm form and the exponential forms of these. So if I have something that looks like log of a equal to b, this can be rewritten as 10 to the b equal to a. And essentially what this is because our logarithms, when it's in the logarithm form over here on the right, when I know what that is equal to, that is telling me the exponent on my base of 10. So whenever we know what the logarithm is equal to, that's essentially telling us the exponent on 10 of what that would be. So let's do an example without having to use a calculator here first. And I want to figure out what the logarithm of 1000 is. Well, I'm going to imagine I am setting this equal to b. I want to know what this is equal to. Here I am trying to figure out what this exponent would be on 10. So 10 to the what power is equal to 1000? Well, we can figure this out without a calculator if we just do some mental math with this. 10 times 10 is 100, so that's 10 squared, multiplied by 10 again, and that gives us 1000. So that means we need 10 to the third power, which tells us that log of 1000 is equal to 3. The next one, I have log of 1 over 10. With this one, it's helpful to think about some exponent properties that we haven't actually talked about in this class. But if I have 1 over, say maybe m, this is the same thing as that denominator m raised to the negative 1 power. So whenever we have 1 over something, we can bring it back up to the numerator spot of this, get rid of the fraction, if we just make the exponent negative. So our log of 1 over 10 is the same thing as log of 10 to the negative 1 power. And now here we already know what we have on the inside, 10 to the negative 1 power. Well, that exponent on this 10, that is our b for this. So that tells us that log of 10 to the negative 1 is just equal to the exponent of negative 1. The next two, we have been given what the logarithm is equal to, and now we want to know what is on the inside of the logarithm. So we have log of x equal to 7. So this means that I have been given my exponent on 10. So 10 to the 7th power, and now that is equal to our input of the logarithm, which is x. Similarly, the next one, log of x equal to 1. This means that we have been given the exponent on 10, so 10 to the 1st power. This is then equal to x as well. Okay, the next one, I want to be able to solve this logarithm using a calculator. A lot of times we're not going to be able to solve logarithms in our head by solving it like the last ones, because we essentially need to be able to have it be powers of 10 to be able to do that. Otherwise, it might be pretty hard. So this one, we're going to practice with the calculator, essentially to make sure that you are putting this into your calculator correctly, you're using the correct logarithm and getting the correct decimals for this. So if I have log of 0.64, we want to find the logarithm button on the calculator. Your standard scientific calculators, it should be somewhere in the top left section of it. Usually the same button as the 10 to the x power, if you use the second key for that. So if we input log of 0.64 and press enter, you should then get negative 0.1938 for our answer.